Why are the planets different sizes? Does the nebular hypothesis predict that Earth, Mars, Venus, and Mercury should all be different sizes? The nebular hypothesis doesn't predict any of that. And I want to make it clear to my listeners that stellar metamorphosis has grown significantly. And now I'm going to begin branching off with the ideas and developing each principle as secondary to other principles. I mean, every principle I have, I'm going to have secondaries and tertiaries and all the way down the line, and it's going to start growing bigger and bigger and bigger. So that's one reason why I make these videos, is because I don't want people to be lost. I've come a very, very long way now, and it would be very easy for somebody to just lose track of what I'm working on. This paper is called The Mass Modeling Principle of Stellar Evolution. I'll read it out for you guys because it's nice and short. It's not that bad. In stellar metamorphosis, stars lose mass as they evolve. Therefore, a simple principle can be drawn up regarding their mass loss and modeling for future scientists. In order to correctly model stars' evolution into life-hosting stars such as the Earth or others, you can call them asteroids if you want, the variable of mass loss needs to be included. What this means is that any model of the internal structure of a star is not sufficient to determine its future, as mass loss will change all the other variables over time. So think of it as like the Drake equation, where you have this variable, this variable, this variable, this variable. The mass loss variable is probably one of the most important variables in the star's evolutionary path. And that's also completely ignored by the establishment, because to them stars don't lose appreciable mass, and definitely stars could never become colder, older, dimmer, less massive stars, because obviously if they were to see them, they would call them planets and exoplanets. Anyways, on to the paper. This is observed in the different structures and compositions of stars in various stages of evolution found by Kepler and even the classical planets in the solar system. It's found that they're all different masses. In short, trying to determine what the future of a star's physical and chemical structure without significant mass loss as a variable will lead to wildly inaccurate assessments of the star's evolution at most stages of evolution. A star's current structure, elemental or molecular composition, radiance, phases of matter, etc., cannot be used to determine its history unless mass loss is taken into account. What this means is that when you look at the Earth, Mars, Mercury, Venus, Jupiter, Saturn, all the classical ones, and even all the exoplanets, you can't look at them as they are. You have to look at them as objects that have lost a considerable amount of mass, many, many, many magnitudes more than where they're currently at. That also being said, this principle diminishes in importance as a star stabilizes and loses mass slower. Thus, older stars such as Mercury will not change considerably, so can be modeled much easier, as the mass loss and rate of mass loss will be much less. All that means is that if you're going to figure out what something will become in the future, chances are more likely it's not going to change all that much if it's completely solid and it's not losing any mass at all. Or not losing any mass at all, but losing mass extremely slowly. And the Sun is losing a lot more mass than Mercury is, by far, as well. What tends to be is that the larger the object, the more helium and hydrogen it has, the more of that material is going to be lost. So clearly that's, and it couldn't have combined with other elements too, making heavy molecules. Basically, this means the more massive the star, the more possibilities for its structure to change in different ways. For instance, you could have two Sun-like stars, and both lose mass at about the same rate, but then they could have their orbits interrupted, and one orbit a hotter host losing mass faster due to photoevaporation and that kind of stuff, thus not allowing for more material to be deposited in the interior, forming the planet. What I mean by that is if you have two stars and they are about the same age, same mass, everything, and then one takes up orbit around a different host, very, very close to that host, you know, when it moves into brown dwarf stage and it gets ripped apart a lot quicker, and the other one becomes a rogue object and can just wander the galaxy doing whatever it wants to do, and it's not around a hotter host to rip it apart, that one will deposit more material in its center, making the inner planet that it forms much larger because there's more material to work with. That's how you create super Earths, and that's how you create objects that have more material in them. That's why Earth is larger than Mars, is larger than Venus, is larger than Mercury. It had more time to deposit the material. Those objects didn't have all that time. And obviously you have even smaller objects like Callisto, Io, and those objects, those thick atmospheres were ripped away way, way, way more quickly than even Earth was. That's why they're a hell of a lot smaller than the Earth. So two stars that started with the same properties mostly, but one losing mass faster due to evaporation caused by the hotter host, will lead to two different sized planets far into their evolutionary timeline. This is why all planets will be different sizes and are observed to be different sizes. The nebular hypothesis, the protoplanetary disk, all the models that are accepted by establishment astronomy are false, and they have no way of explaining why these objects are different sizes. This is why. The amount of time and the amount of material that is needed to form a planet is dependent on the rate of evolution of the star itself as it forms the planet in its interior. And that is due to the amount of mass loss that it has over time. And this is what I'm going to use as a backdrop, as a main idea in this theory development, because it's basically the Achilles heel of establishment. They can't have anything losing mass, and because they can't have anything losing mass, they can't actually describe or explain anything that they're observing in outer space. That being said, I'll just keep this talk short, but yeah, for those that are new to the theory, here's the little diagram that the star evolves on as it goes down the line, and it loses mass, becoming the planet. From now on, I think I'm gonna link this to the bottom of the page, as well as the papers that I talk about. All right, y'all. I hope you understand what's going on with this, and when you read articles, keep that in mind. Keep in mind that these astronomers, they don't like instability. They like things to be perfect, with perfect orbits, with perfect this, with perfect that. But as it turns out, nature is very chaotic, and there are variables that have been ignored by the experts, which is why, you know, they're not necessarily the experts anymore. And that's unfortunate, because I've been trying to warn them about this problem for the past 6 years, and they continually ignore me. So I guess that's how things are going to go down, and so be it. Alright, y'all, later.